So here's something that looks a little bit different, right? I mean, it's not squareds anymore. We got fourth powers and things like that, but it's a special case. It's going to be an equation that's in a quadratic form. Now, quadratic form means you might have higher powers, but it's going to pretty much be the case that you're going to have a constant, something with no variables on it at all, and the powers on the other portions will be whatever the highest power is, the other power will be exactly half of that power. So to kick this off, we're going to start this with getting 1 set equal to 0. That's what we're going to do. So I'm going to add a 10 to both sides, and I'm going to be left with something like y to the 4th minus 7y squared plus 10 equals 0. And then because this highest power and this power, this is half of this, or this is twice as big as this, however you want to look at it, the relationship of this is 2 to 1. We can think of this as if it were, I'm going to use a u because I like to use a u squared minus 7u plus 10 equals 0. And kind of in the back of our minds, u is equal to y squared. See how that's working? The idea is that if I let u equal y squared and I square this thing, if you square y squared, you get y to the 4th. So if I'm going to call this thing u, it's fair to call this thing u squared. And that's why the relationship of this always being half of this or this being twice as big as this is so important. Otherwise, this doesn't work. So this could be like a y to the 6th and a y cubed. And then u would equal y cubed. Or this could be a u to the 8th and a y to the 4th. And then if you square that, you're going to get this. So it doesn't matter. As long as this is twice as big as this, you could do something like this and then make u equal whatever the lower power is. And now I'm going to go ahead and factor and solve and do all that kind of fun stuff, but there's going to be an additional step. So reverse foiling here. The only way to get a u squared is with a u and a u. The only way to get it, well, if I can do 10, it could be 2 and 5, or it could be 1 and 10, but since there's a 7 over here, I'm thinking probably 2 and 5 is the way to go. They have to have the same sign, but they have to add to make it negative. So if these are both negative, quick mental check, I'd have a negative 2u and a negative 5u. Those would combine to make negative 7u, so that's cool. And then if I set each of these equal to 0 and solve it, it's not too much work to see that u equals 2 and that u equals 5. But we are supposed to solve for y. So now that we've got this down to just a simple u and a simple u, let's replace that u with the original variable, y squared equals 2, y squared equals 5, and now we have to solve this. And this is where I hope you guys remember some stuff from your Algebra 1 class. If I square root something and I square root something, if it's not a perfect square, we're just going to leave it under the square root symbol. But the other thing is, there's two things you can square to get a 2. It could be positive or it could be negative. Because if you multiply a positive by itself, it's positive. If you multiply a negative by itself, it's negative. So I'm going to put that plus or minus in here. And likewise over here, I'm going to have plus or minus and a radical 5. So square root and I'll square root. And because it's me with the square root in, I got to remember to put that plus or minus in there. So these are our final answers. If you have questions about why this plus or minus stuff is happening or how to deal with these square roots, please let me know, because I know you guys learned this in Algebra 1. I talked to Miss Masak about it, Miss Levin, but it's a topic that might require some review, and I could put together a video for it if you want me to. But if I don't need to, I'm not going to. But I'm happy to do it. Totally happy to do it. Okay. Good luck, guys.